All right. Well, we'll go ahead and get started. So yeah, this talk is Nick's a deep dive. So if you're part of the previous session, Zach was going over how to use Nix on Replit and how you can use that to create really great environments. We published like 3 or 4 different languages just in an hour. So that's really awesome. And this talk is going to be a bit more technical, going into the details of how Nix works, kind of the fundamentals behind Nix and why it's different from other package managers. So introduction about myself, I'm Connor Brewster. I'm a platform engineer here at Replit. I've been here for a little over a year and a half, and I've spent a lot of my time integrating Nix into the platform. And so all the things that we were able to do in the previous session are kind of the fruits of that work. Being able to quickly add packages has been what we've been working on. So first, before we really get into what Nix is, we need to understand the problem that Nix is trying to solve. Right, and it's this fundamental problem with computers. You get a computer, you get some hardware, and you want to install some programs on it, right? And so you might download some software, and over time, software gets really complicated. Software depends on other pieces of software, maybe slightly different versions of other pieces of software. Managing all this by hand would not be fun. So we've invented package managers. And there's a lot of these that already exist. You might be familiar with like apt or Pacman or Homebrew if you're on Mac. And Nix, maybe you're familiar with it. If not, I'll be talking about that today. So let's talk about some of the problems with traditional package management. We have this really frustrating problem where something works on my machine and then it doesn't work on someone else's machine. So it's like, okay, I run this command on my computer and it worked fine. Somebody else runs the same command and it has an error. And now you have to figure out what's the difference between the two machines. Maybe you ran all the same commands and everything should be the same, but it's not. And you waste a lot of time and energy dealing with problems like that. It's not great. You also have problems where maybe two pieces of software depend on two different versions of another piece of software. And so if you're lucky, the package manager can maybe resolve some of this for you. If you're unlucky, you are stuck Googling around and trying to figure out this problem. You also just installing packages through the terminal. Maybe not everyone's this way, but it's really easy to just keep installing lots of packages and then you never go and uninstall things you don't use anymore. You just copy and paste commands to go and install packages all the time. And so you accumulate so much cruft over years, and eventually you get a new computer and you just start over because there's no point in trying to transfer all this stuff. You just want a clean start. And for the most part, packages are installed system-wide or user-wide, which it doesn't really make a whole lot of sense. Maybe you're developing on some project and that project has some specific dependencies, right? Why should I have to install those dependencies on my whole system, right? I should have some way to isolate those dependencies to that project. And you also find a lot of projects on GitHub, if you want to contribute to them, they'll have instructions like this, where you go and copy and paste all these apt commands, and this will install a bunch of packages. If you're lucky, everything just works. But most of the time, there's problems. So maybe the developers are now depending on a new package and they forgot to go update the README, and now you have to figure out what the problem is. Or you run the command and an error is out, and now you have to figure out what the problem was. This is not great. But luckily, there's a better way, and that's what we're talking about today. Nix provides us some better tools for handling this kind of a thing. So here are some advantages of Nix that I'm highlighting here. So first off, reproducible environments, right? It gives us the tool to create environments that function and work the same way on my machine, on someone else's machine, today, a year from now, and that's super powerful. You spend a lot less time debugging these weird issues, trying to figure out what changed in a system. And so, you spend more time actually working on your project than debugging something on your system. And a part of this is you can define environments through code. And so instead of having a README where you copy and paste commands, you can have a file that specifies all of the dependencies needed for your project. So this is really powerful. Nix also comes with just tons of different packages. You can use it for developing projects in lots of different languages. You've got tools for Rust, Go, Python, Node, you name it. It's probably in Nix. In addition, you can use Nix for configuration. So it's not just a package manager. We'll talk about this a little bit later on, but you can use it to manage your full system or your user configuration. And that's really nice. And along with that, You have rollbacks. So, maybe you experimented with your configuration, changed something, and you completely broke your computer. You can just roll things back and it will work just fine. And that's like really powerful with Nix. That allows you to fearlessly experiment with things, which is really nice. You should be able to try like a new Linux desktop environment, and if it breaks, you can just roll things back. Not a big deal. So, to understand like how Nix is able to accomplish all these things, we need to think about like the fundamentals, like how does Nix work at a base level. So I've highlighted 4 of like the primary components of Nix. And first we have like the Nix language, we have derivations, the Nix store, and Nix packages. And so we'll go through each one of these and kind of explain the role that they play in this overall system. So the first thing is the Nix language. So it's a purely functional language, which, fancy words. I'll talk about what that means. It's not too complicated. It's lazily evaluated, so it's trying to minimize the amount of work it has to do. And it is designed specifically for writing derivations. And we'll talk about this in a second. But it was designed specifically for package management. And so don't try to use Nix, the Nix language, to go write a web server or a video game or something. It was not intended for that. It's not a general purpose language. And if you're not familiar with like functional programming or anything, the syntax might be a little odd. So like here's an example of some Nix code. And this is a function that takes in a first name and a last name, joins them together to create a full name, and then outputs a string with the full name. So there's some resources that I'll link up if you want to like learn the syntax and how to use the language. We don't have time to cover all that today. But we can talk about some of the properties of the language. So when we say that a language is purely functional, there's a couple of properties that are important. So first off, if you have a function and it takes some inputs, if you specify the same inputs, you always get the same output. So a simple example of that is a function like this one where you add 2 numbers, right? If you pass 1 and 2 into this function, you always get 3 out. And so, every single time you can do this 10 times, you'll get 3 out. And that's really nice. That actually lets you shortcut because, let's say you've called this function once and you know that with 1 and 2, it outputs 3. Next time you want to call this function, if you put 1 and 2 into it, you already know what the answer is going to be. Now contrast that with this example beneath it, where we have this local time function where you pass in some UTC time and it magically converts it to your local time on your machine. This function will like work differently depending on your geographical location. And that's really bad. We don't want packages to build differently depending on like where you're located at that time. So a better way of specifying this is taking all of those implicit dependencies in your environment and making them explicit inputs. So we could have a function here that takes in a UTC time and some time zone and then outputs a time. And this doesn't have any sort of implicit dependencies. And then also, the language is lazily evaluated. So I only mention this because it's a little confusing when you first get started, but it's a really important property. So there's a thing called Nix packages, which is where all the packages are defined, and it's one just gigantic Nix expression. And if Nix eagerly evaluated everything, it would take a really long time for Nix to go and evaluate all of that. So instead, Nix just evaluates the bare minimum. So in this example, we have like foo and bar, and we're using this trace function to print a debug message whenever foo and bar are evaluated. And so we can see in our output, we're only including bar in the output, not foo. So you see that in the output, we only see evaluated bar, not evaluated foo. So Nix did not actually compute 1 plus 3. So this is an important thing to keep in mind. It might be a little confusing if you're not used to using like a lazily evaluated language. So cool, we have this language that really can't do much. It can add some numbers, it can put some strings together. Great, so what's the point? Well, this is the point, Nix derivations. So the language allows you to write recipes for building packages. And you can imagine this as just like one of those functions. Building a package is just like one of those functions. We take in some inputs that could be like some source code, a compiler, maybe Python 3 to run some Python scripts. And then we have some build script that runs, and then output, we have some package. And so we can apply a lot of those same concepts of like functional programming to building packages. So this means that when we build these packages, we must define like all of the inputs. And this means that like if we have all of the same inputs and we run this, we should get the same package out every single time. And this is a really important property of Nix, and it's really important for ensuring reproducibility. That property where I can build something on my machine and somebody else can build something on their machine and they work the same. And that's really important. So you might ask, like, how do we write a derivation? So if you were in the previous session, we've been using Bazel as an example here for writing a derivation. It's nice because the derivation is pretty small. But this is a language that won our language jam about a year and a half ago, and we just added it to Replit. And so this is the derivation that Zach wrote. And so let's go over this like briefly. This is a function. It takes in some inputs. So we have standard environment. This includes like a C compiler and a few other utilities. We also have Python 3 because we need to run some Python build script. And then we have a function to fetch some code from GitHub because that's where the source of this package actually exists. So we can call the make derivation in the standard environment. We can give our package a name. We can fetch the package from GitHub. So we specify the owner and the repository and some specific revision. And we want to make sure that we pin everything. We want to specify a specific Git SHA instead of a branch. So for example, if you put like the main branch here and you call this function today, and then somebody goes, adds some new commits to the main branch, and you evaluate this tomorrow, it's going to have two different things. And we can't allow for that. Everything has to be pure. And so you want to use a revision here. And Nix is even a little bit more paranoid. You have to specify this SHA-256. And this seems a little confusing. But Nix will use this to ensure that what it fetched from GitHub is what you expect. So what Nix will do, it will pull this code down. It will take the SHA-256 hash of that package, and then it'll match it against this and make sure that it matches. So if something did change on the remote service, it'll let you know and the build will fail. So either you have a successful build where everything works as expected, or you have an error and Nix will tell you what went wrong. And then now we have like a build and an install phase. So for building, we just run that Python build script, which will build a release version of Bazel. This outputs it into some binary directory. And then in the install phase, we just copy that output binary to the output directory of this package. Now, when Nix actually evaluates that function, it creates what's called a derivation file. And this is like a recipe for building a package, but it's very specific. It includes all of the ingredients, and we have like these special names for them, and we'll get to that in a second. And it includes the steps of like how to actually build this package. And then you can realize this package. It's a term for actually taking this package or this derivation and turning it into a real package. And so the Nix build tool can handle all of this. It can handle evaluating your expression and then actually building the package for you. Now you'll notice we have these gibberish names, and these are pretty important. Right, going back to that concept of Nix being a purely functional language, we know that given the same inputs, we always get the same output. And so we can create a unique identifier for each package based on the inputs. And we already have this derivation file, which specifies all of those inputs. And so what Nix does is it takes that derivation file and hashes it and generates something that looks like this. And this is a unique identifier for that package. And one of the important properties is if any inputs to that package change, that could be like the source code changes, it could be you're using a different version of a compiler, then this hash will change. It will be fundamentally a different package. And so this signifies that the output might be different. It's possible that it could have the same output, but there's no guarantees. So you can't rely on that. So, now we have this way of, evaluating these Nix expressions and building these packages, but where do we put all these packages? Where do they live? So they live in the Nix store. I found this, there's a Nix store in Nix, Texas, but this is not where all the packages are stored. It's actually on your computer at /nix/store. And if you look in this directory, you'll see a bunch of stuff like this. And I will warn you, don't list the Nix store directory in a REPL because there are so many packages in there. So it will just break your REPL. But you'll notice that we have this first part here. This is that unique identifier that we talked about before. And then we have this human readable package name. But what's really important is the fact that we're including this unique identifier for these packages means that we don't ever have any collisions in the Nix store. So for example, I looked on my machine and I have two different versions of Node.js 16. 13.2, which is kind of weird. So that means that, maybe one of them was built with a different compiler or something. I don't know the difference between the two, but Nix keeps track of the difference and knows that, these two packages might be subtly different, but they can live side by side in the Nix store. That's no problem. The Nix store also tracks all of the dependencies between these packages. So it knows which packages depend on other packages. And this is really important because, as you update your system and, install packages for particular projects, this directory starts getting pretty full, and, you don't have infinite space on your machine. So eventually you'll start running out of space. And so Nix can do something called garbage collection. It will detect which packages aren't actively in use by your machine. And then it can go and free up, delete all those packages without worrying about breaking your system. So you don't really have to know like which one of these are still in use or not. You just ask Nix, hey, please free stuff up, and it will do that for you. Now, up until this point, like we have a system for building packages and putting them into a store. But, we don't want to build everything from scratch. When I update my machine, I don't want to rebuild every package that's on my machine from scratch. That would take just way too long. And so, since we have this mechanism, we have a unique address for each package, and we can compute that address without actually building the package. We can get that first. Well, we can pre-build these packages, put them on a server, and then before you go and build the package, you can generate that ID, go talk to a server and say, hey, have you built this package? And if that server has, you can download that package instead of building it yourself. And so, the NixOS team maintains a big builder farm that builds all of these, pre-builds all these packages. So when you're installing packages on your machine, for the most part, you're just downloading things. You're not actually building them on your machine. But if you do have a package that's like a custom package or something, Nix will also happily build it locally. You kind of get the best of both worlds here. So now we have a system where we can build all these packages, we can cache them all, but now we actually need some packages. So that's where Nix packages comes into play. It's a collection of derivations for building over 80,000 different packages. So, if you want to install, whatever tools on your machine, if you want Firefox, right, this is defined in Nix packages. And so this is what's available on Replit. We have those binary cache servers that go and cache pre-built versions of all these packages. Well, we just go and download those and pre-seed those in all of the REPLs. And then, when you access a package from Nix packages, you have instant access to those packages. And if you want to add a package to Nix, so let's say, you've created your own amazing tool or programming language and you want other people to use it, this is the place you go if you want to go add this to the Nix package manager. So there's a link to the GitHub repository. You can open a pull request there. Everyone's pretty friendly. But if you're just wanting to use Nix packages and you want to see what's available, you can use the NixOS search. And so this is a really great way. If you kind of know the package that you want, but you don't know the specific package name, you can go there and search it. Cool. So, those are the fundamental like building blocks of Nix. But on top of that, we can build some even more interesting stuff. Oh, and someone wants the link. I'll put that in the chat. There we go. All right. So the first one is NixOS. So up until this point, we've been just talking about the Nix package manager. And you can use the Nix package manager on pretty much any Linux distribution. You can use it on Mac. You don't have to have NixOS. So if you kind of want to try it out, that's a great way to kind of dip your toes into Nix. But if you really like it, you can run NixOS, which is what I run, and it's a full way of configuring your whole operating system with Nix. So instead of just using Nix to build packages, we can use Nix to configure the whole system. So, for example, let's say I want to run a Minecraft server on my machine. Well, there's all these predefined modules for setting up these services. So there's one for Minecraft. I can just add this to my system configuration, enable my Minecraft server, set up some of the things, the port that it's going to run on. And then when I apply the system configuration, Nix will go install the Minecraft server. It will go generate the configuration files, put them in the right place, and it will start the server for you. It does it all. And then, let's say you're done and you want to clean things up. You can delete this from your configuration file, reapply your configuration, and Nix will handle cleaning all that up for you. So you have this really declarative way of specifying like how your system works and what services it has. And then you can even share this configuration with other people, or you can share it between your different machines. It's really nice. And you can also roll back your system. So like I was mentioning before, maybe you tried a new Linux desktop environment and it broke some things. There's a single command you can use to just roll back your configuration to one that works. And then, you don't have to worry about completely bricking your system and restarting from scratch. So, at the beginning of the talk, I showed a slide where, you have a big README that, wants you to copy and paste some app install stuff. We need a better solution for per project dependencies. And so Nix shell is a really great tool for this. It allows you to create a bash shell that has specific packages installed. So for example, if I run nix shell-p python 3, it'll drop me into a bash shell that has Python installed. And it didn't actually add Python to my system environment or my user environment. It downloaded it to the Nix store, but it didn't add those to those environments. It's only isolated to that Nix shell. And even better, you can create a shell.nix file, and you can specify lots of packages in there. And then when you're working on that specific project, you can use Nix shell to jump into an environment that has all the dependencies that you need for that particular project. And so each project can have their own development environment. They're isolated from each other, and you don't have to worry about messing up your system configuration. And if you want this process to be even more automated, you can use tools like durenv or nix-durenv, which means when you use cd and change into the directory of a project, nix-durenv can automatically drop you into that Nix shell. So this is what I use in a lot of projects on my machine. So I can move around to the different projects, and I'm automatically in an environment that has all of the dependencies that I need when working on that project. I don't have to think about it anymore. Now, there's also a tool called Home Manager. This one's really cool. If you've seen .file repositories, it's where people might have their Vim or Emacs or Tmux or terminal configurations. And usually it's just a pile of a bunch of configuration files and bash scripts. Well, you can use Nix to manage all of this. And so Home Manager is the tool for that. You can configure everything in one language. You get those nice rollbacks if you accidentally break something. I put my config here if you want to go check it out. It's really great. And of course, you can use it on Replit. Right. So as Zach said, every REPL is powered by Nix. If you want to add some more packages to your REPL's environment, you can use the replit.nix file, add your packages there. And you don't have to wait for these packages to download because we already know all of the set of available packages that you can add. And we've already downloaded them and pre-seed them in all the REPLs. So you add the package and you don't have to wait for things to download. And this is just using Nix shell under the hood to generate these environments for us. So, if this is interesting to you, here's some places to begin. Nix is a bit hard to get into. So, we're trying to make, better resources that's, more beginner friendly. But, the best way to get into it is just to dive in, install Nix. If you really want to get into it, NixOS is really awesome. There's some resources for learning just the language itself if you want to learn that, or some resources to learn the package manager. We also have some of our own docs on how to use Replit or Nix on Replit. And I've also put links to my configuration files and Zach's configuration files. It's going and reading other people's environments and configuration files is a great way to go learn how this works and to get some inspiration. So that's pretty much all I have prepared. At this point, we can maybe take some questions. I haven't been looking at the chat too much, so we can find some questions. If you have a question you want answered, you can post it again in the chat. And also, I'll post a link to the slides here, so you can go find all the links that are on there. Yeah, so Breno asks in the derivation for Bazel. So let's go back to that. Let's see. That we're not specifying any particular version for the standard environment or Python 3 or fetch from GitHub. So currently with Nix, there's this concept of channels where you have, either for your user or for your system, a pinned version of Nix packages. And that is where all these versions come from. So whenever you update Nix packages, it'll update the rest of the system. There are some projects in Nix. There's a thing called Flakes, which appends Nix packages because you could have two people with two different versions of Nix packages, and then things don't feel as reproducible as Nix claims. So Nix is the Nix team and the community are trying to find better ways of pinning these things. There's a lot of options to make things even more reproducible. So someone asks, can you use Nix? Is Nix just for like installing Node or Python? Or can you use it for installing dependencies from like package.json or requirements.txt, like language level dependencies? So with Nix, you can, for some languages, pull in dependencies for particular languages. Like there's a lot of Python packages that you can use. You kind of have to like really buy all the way into Nix and use those. You can't use like Poetry or a lot of the standard tooling for the languages. So, in our Python REPL, we do a little bit of magic where we're pulling Python from Nix, but we're still using Poetry to manage all of the dependencies. But that is an option. You can, if you really want to buy all the way into Nix, for some languages, you can get dependencies. All right. Well, I think that's about all we have for time. So thank you, everyone, for coming. I hope this was helpful.